I hope you have enjoyed watching these videos on Remix. It really is a fantastic tool, and I use it quite a bit in my own projects. I want to focus on the behind the scenes stuff here. What happened when I selected my inbox contract here and I typed in some argument and then here and then click the create button here? What really happens on the Ethereum network when we try to deploy an instance of a contract? I want to pull up an old diagram once again. Let's see, I may still have them up. Yeah. And so kind of want to put these side by side for now, and then I will share my screen with you. All right. And we share. How do I get these? Well, show this one first. Why don't we do that? All right. So I'll show you this one first. All right. So if you recall, I set up an account with MetaMask, and then I used this R.I.S.E network. Or the R.I.S.E, actually what I used, I was in the R.I.S.E network, but what I used actually was, I'm going to head to that page. So I used this rinkbfaucet.com, R.I.S.E test faucet, to send some Ether to the account I had created on MetaMask. So that was a transaction that sent money from one account to another. And I spoke about the transaction object that was used to represent the movement of money, and I'll pull that diagram back up soon. I also spoke about the different properties that this transaction had. And when I create a new contract, a very similar process occurs. So let me see if I can go back to this diagram here. All right. So creating a contract is very similar to the transfer of money between two parties. The differences are small, and I want to use these diagrams to demonstrate those differences and talk about them. So just as before, to send money from one person to another, we're going to take our account and author a new transaction. And this transaction will have a purpose of trying to create a new contract. So we're going to send it from one account. So for example, from this account, and we'll send it to a specific network such as R.I.S.E here, which attempt to actually create the contract. So let's talk about the actual transaction object being used to create the contract. All right, so now is a good time to pull up the other diagram and close this one. Here it is. I'll expand this some more so you can see it. All right, so this is an external account to create a transaction. So nonce here, nonce is recording how many times the sender is sending the transaction. In this case, the sender is trying to create the contract. In the context of Remix, some of these sender things might seem weird because when we were in Remix, it doesn't look like we're interacting with anything. And next, we have this to field. And the big difference between a money sending transaction and a contract transaction is that this field is left blank when we're creating a contract. So if I send a transaction into a network and I leave the to field blank, it means I'm attempting to create a contract. The Ethereum network will automatically assume that you're trying to create a contract if you leave the to field blank, and it'll actually create an empty contract if we don't include any code with it. So just the mere fact that I leave this to field blank results in a contract being created. The other property that we need to be aware of that results in these transactions being created is the data property. And I actually don't have that property here in this diagram, but no matter. We'll still talk about it. What was I talking about? The data property, right? give me a second here. I wish I would have included it because now it's kind of thrown me off. So, all right. So the data property, this is the actual compiled bytecode of the contract. So this is where the code that comes out of the Solidity compiler is sent in and stored in the network. Now, specifically, the code gets stored in the account we created that represents the actual contract. So whenever you write a contract and deploy it to a network, all the code, or at least the raw byte code, is available for everyone else to see. So there's really no inherent security of the code that we write. So usually whenever we write a contract, we don't put some secret business logic in there because everything in there is exposed to the world. All right. So the last thing, these contracts will be signed with these V, R, and S values or properties, which are derived from the sender's private key and can be used to derive the sender's public key. A transaction that's being used to create a contract can be assigned a value here, and the contract created will have a balance of ether. So in one step, you can create a contract and send it an initial amount of money. That's the contract creation process in a nutshell. So in a subsequent video, I'm going to talk about the difference between the return data, get data, and modify data functions. Stay tuned.